I do just kind of a heads up while we're getting this ready. I do a lot of continuing education for structural engineers. So if you're part of a structural engineering association and you're looking for a monthly speaker, please reach out. I do an intro to GFRP, and I'll be doing a version of this as well, depending on your office or your plan checkers or any type of group that would like some more information on this. Please reach out. It's free of charge. I'm just trying to boost this industry up. I love it. So I basically say I sell this because I love it. I don't love it because I sell it. So I really want to get this more readily available and into the hands of engineers so they can see the inherent properties of it. So I am a design engineer and I live and breathe the code. Sadly, I spent a lot of money on the code because of that. I joined the 440 when I heard about the amazing things they're starting to do in ACI 440. I used 440 20 years ago when it was a design document to do my research. And the main codes I did use were European and Canadian because the United States didn't have much. So I really want to go through and show you that the United States is catching up. We're going to have our code too. So really right now, the ACI 440.1 is a design guide. I get a lot of pushback from building departments going, it's a design guide. It's actually not listed in your IBC, so it's not a reference in the building code, so they're not going to take it. Well, come next year, I'm going to be like, no, I have a design code. Come on, look at this. So that's the really cool thing. We just got all our comments back from TAC. So we are going through and getting the code ready. We are looking at the end of this year to get this done. So that means Christmas time, you can treat yourself to a new code book for Christmas. Well, that's just me probably. So the current one is set up with 12 chapters. It's pretty simple. It is a design guide. It goes through, it has a lot of information on the history, what it's good for, the pros and cons. It goes through all the different types of FRPs. So it does discuss aramids and carbons and all the other type of strands. But this design guide's really helpful. I live and breathe right now in Appendix A. So I have a lot of contractors that go, I don't want to use welded wire mesh. Do you have an option for me? So I go, well, where are you doing your control cuts? And they're like, oh, every 10 feet. So I can go into this Appendix A and I give them a GFRP option. And they're really enjoying that option. The code 440, everybody, if you're a designer, 318 is right next to you when you start designing. 440 is going to look just like 318. So we're going to go through why you're going to feel very comfortable with this 440 document in a little bit. It's going to have the exact same chapter layout that took me 20 years of designing with ACI, and then they changed all the chapters on me. I don't know if anybody else was upset with that, but they're going to mirror the new layout. So you get used to the new one. The 440 is going to mirror the new one. The big difference is it's only going to be glass. So no basalt, no carbon, no aramids. It's only going to be dealing with glass. So that kind of gives you a good first start. Just jump in and get to know GFRP and how to use that in buildings. It's going to be really helpful. The two big new things that the code's going to introduce that the current design document does not is now you'll have a way to design columns and walls. And we're going to go through that in a little bit. So you can kind of see what is new. It's a lot of the beams and the slabs and all that design that's already in the current document are all going to be moved over into the code. So nothing's going to change there, but you will have columns and walls now. So it's going to be chapter 10, just like 318. We're not going to be dealing with exactly all the things that 318 allows us to do. So it does have limits. But I'm okay with that. I just want it out there. And if you have a kind of construction that you can't do with the new 440 code, go back to the old way of doing things. It's not going to hurt us for a few years to mix and match. I think I think having more options is going to give the industry a better feel of what we do and our value. They can't just go to a table and go, I want this. Now, well, if you do that, do you want this, this, or this? So we're giving them the bigger option of how to design their buildings. Green, cost effectively. There's a lot of pros and cons for this. One thing to be aware of, I know Josh brought up the clear cover. Clear cover is extremely important when you're dealing with fire protection. So don't get into your head, oh, I don't need my 3-inch clear cover anymore. It might be necessary because it is glass. We do have a temperature limit on that we need to take care of. So we don't want to do fire coatings like we do for steel. So we may need a little more concrete to deal with the temperature of the rebar. We don't want it melting. Chapter 11 is our cast in place walls. I have a lot of contractors that are already moving this way, even though it's not codified. They're loving it. IRC designers don't even care that it's not in the code. They want this for their walls for IRC. The big thing that I'm seeing is all of our ICF contractors are moving from, because you got lightweight formwork, why not use a lightweight bar with your lightweight formwork? So I just talked to a contractor yesterday. He was designing a wall with number 6s. And he goes, can you give me a lighter option that I can drop into my formwork? And I go, how about our bars? And he's like, I love it. I'm going to go pick some up at my supply. So that gives you some ideas that contractors, when they realize they can pick up a whole stick by themselves and drop it in, no problem, they're really jumping on board with these type of wall applications. So this might be a big tool to have in your pocket when the code does come out. So right now I do say I have my 440 handy all the time. I've been designing GFRP for about 10 years. So it's hit or miss. The biggest miss is seismic. I'm from California. And so everybody knows California equals earthquake. This is not a great product for earthquakes. Right now, I should say it's not ever going to be a great product. We need a lot of R&D to see the ductility issues and the energy. I wouldn't say ductile. I think we need energy dissipation. So how are we going to deal with GFRP not being ductile, and how do we get the energy dissipation needed for earthquakes? So right now, though, if you have options that are not seismic, there is, especially for students, they have 11 examples fully vetted in the back of those, metric and imperial. I don't look at metric because I'm a US designer, but it does have a lot of really great examples. So I've got quite a few of these that I've already put into my Excel spreadsheet. So they're ready to use, put them in your spreadsheet and they just plug and chug. It's really easy. So right now I'm going to go through, okay, you're doing new things that aren't in the 440 yet, kind of walk through what to expect when we do get columns and walls. The first is our columns. You're not going to change anything about how you determine the size of your column. It's still a compression element that's carrying load. Size it just like you always do. No changes there. And again, I would always say ACI has some great examples. If you're not using a software or you're not using a modeling or an Excel spreadsheet, they have some great, like, exact step-by-step ways on how to design these columns. So the big difference is finding your longitudinal and shear ties. The big thing to be aware of is because GFRP has two different modes, because it's not ductile, we have like an overstrength factor to account for that. So the tensile capacity of the bar is really similar to steel, but we have a really interesting usage there that we need to be careful that all the different load combinations still are within the usable space. It's the same with steel, but this is just something to be a lot more aware of. And we need to make sure that the strain in the bar does not exceed the 0.01 strain. So that's just another little check, one check extra besides our typical concrete column design. So we talked about bends earlier. The code does have a few things that are not allowing in the current for glass fiber reinforcement. The bends, the offset bending and detailing, so when you go from column to column, those are not allowed in the new GFRP code. So that's just something to be aware of. That detailing might need to change in your your back pocket if you do have these standard details on hand. And be aware that a lot of any shape cannot be filled bent. So be aware that your contractors need to be aware that they can't order a whole bunch of number 3 and filled bend it. So they need to be very aware that there are some limitations, but there are pros and cons to that, I think. I think it's nice that all the shapes show up on the site and they can just start installing. They don't have to have a truck bed with a jig on the back of their truck bed bending these bars. Another thing to be aware of is there's no current mechanical couplers. I get this question all the time. Can I splice these bars with a mechanical coupler? They're not steel. Everything on the market, all your Linton products don't work because they're designed for steel. So just be aware of some of your typical splice details are not going to work. So you need to do more lap splicing and just be aware of heavy loaded columns with a lot of rebar might be problematic. So that was really the only difference for columns. Cool, right? So you're just like, oh, steel, GFRP, I don't really have to do a lot of work to change between one and the other. So that's just one nice thing to feel that you have another option to offer a client with very little legwork to get it up and running. Because as an engineer, budgets are important. And I don't want to spend an extra 10 hours designing a column to save the contractor $50. Anybody with me? So that's what I'm just saying. It's not going to take you that. It might take you an extra 2 to 3 minutes to set a spreadsheet option up for you. Walls are a little different. We're looking at an ACI 440 code. We're looking at almost like unreinforced concrete for a lot of options. And we're doing a lot of the detailing is more temperature and shrinkage steel. So we're going to see a lot of those differences. So for the big first one here is you no longer have your 4-inch wall for bearing. Your minimum is 5.5, which is fine because I do a lot of tilt up. So I'm hoping that I can leverage this 5.5 tilt up wall in that because most tilt up walls aren't 4 inches anyways. So that works for me when I'm looking at that. But that's just one thing to be aware of when you're designing walls. You can't go super thin. Basement walls and everything else are exactly the same. The one big thing that we are seeing a little bit of, I would say that we have a little bit more reduction in some of the GFRP. So before this number is currently in ACI 318.19 is 0.55. And you're going to have a little bit more reduction with the 0.45. And as an engineer, if you're not familiar with it, you're like, okay, I got a little breath. There's a little bit of care there that I don't have to feel like it's perfectly the same as steel. Gives you a little breathing room until you get comfortable with the product. In-plane shear is very different. I almost say this goes back to the beginning of my design career. This is how I designed shear walls back in the day. So a lot of the code changes when it comes to in-plane shear for 318, we've kind of almost gone back to the old way of designing shear walls. So we do have a limit on the in-plane shear capacity of the concrete and the steel. I almost want to say it's a little easier. It might be a little more, but it is an easier calc. So the 0.2 F prime C HD, again, that's a really simple calc without having to do all these alpha calcs or your A for your ACV. So that's just something to be aware of. We're also doing the back in the day, everybody knew the capacity of your wall was your VN plus your VF, exact same thing, kind of going back to that, combining the two capacities of your concrete with your steel. So we do have one little caveat here for the in-plane walls. So this is just like little things to be aware of that make it unique. But they're little things and they're not very often. It's just 0.005 for the factor for cracks. We're just trying to mitigate any failures in shear. So because everybody knows shear failures are not the mode that we really want it to happen. If you've ever been in a lab where they're doing shear testing, you think a bomb went off. So it's kind of scary when it happens. One thing, I kind of put this graphic up here. A lot of the graphics are exact same between 318 and 440. If anybody was in the committee, they basically took the 318 and then went line by line and changed it or deleted for the 440. So it really is almost like a side-by-side comparison. So reinforcing limits, that's something, this is the biggest takeaway from walls is the reinforcing limits. So that's just something, it's again, kind of going back to the way we used to do steel. So there's a lot of more of these simple equations that we need to be aware of. So again, these will all be very clearly delineated. And what I love about it, it still has all the commentary just like 318. So you're like, well, why is that different? And you can just read the commentary and you're like, oh, well, all these tests show that this is a better mode of calculating it than for steel. So that has all been in consideration. So part of being ACI is, this stuff has been vetted. It's right on. We have the testing. We're not going to publish it if we don't have any information to back it up. This is the big thing for me is spacing. So I get this all the time. They're like, well, it's 18 inches on center. And I'm like, I can't do 18 inches on center. I have to do 12. And they're like, why? And I'm like, code. We've done it this way forever in steel. Sorry, it's not steel. You've got pros and cons. You might need a little bit more, but I guarantee you, you're either going to love it or you're going to hate it. And every contractor is different, but just kind of being aware, 12 is kind of a good rule of thumb for GFRP. If you get something that's over 12, kind of go ahead and stick with 12. It's just the way to go. And then I have, this is kind of cool. We were with a design software. You're like, oh, I live and breathe by design software. It doesn't have GFRP in it. What am I going to do? I really don't have the time to write new Excel spreadsheets. Well, this is Altair they bought as concrete. And there we go. This is a little demo of a software that's coming on the market extremely soon. So it is based here in, I think it's Michigan or somewhere around there. And they can do all your modeling here. And when you do this modeling, GFRP is your option. So all you have to look at is 40 KSI, we usually have 40 KSI or 60 KSI steel. No one does 40 KSI anymore. But keep 40 and 60 in mind. 40 is your low mod, 60 is your high mod. Keep that in mind. You really, in this type of application, do not do anything but 60 unless you're doing just crack control. They do this whole modeling program for you. So you can go in there, choose your rebar, and they will do GFRP or steel so you can compare. So if you have this modeled and your contractor comes to you and says, no, I want GFRP instead of steel, you can go back into your model, choose GFRP, rerun your model, and now you have your solution. So they're coming on the market. This, again, it looks pretty well done. They're just doing the final beta, making sure everything is working well. This is on Vimeo if you wanted to see their full video of it. And you can always stop by and I can get you contacts. If this is a software you don't use that sounds interesting, feel free to let us know and we can get you in contact with them. But as you can see, it's robust. This is kind of what's like exciting to me is I don't have to yeah, I have to buy a new software, but that's kind of fun if you don't mind paying for it. But it's really nice. And so a concrete software design, it's hit or miss for a lot of engineers. But I love the detailing of this. It helps you design the stirrups, the longitudinal, horizontal bars for everything. So, and then it gives you a really nice printout that you can take and say, and if you're like me and you deal with plan checkers, if you have a computer output that they're comfortable with, they really don't question it. They are like, you know what you're doing, you modeled it, I take your design. So that's just something to be aware of. I am not, I'm a design engineer, so and if anybody has any questions, if you're like, wait, what is the code going to do about this? Or how do I make a comment out of the code or see the code? It's out for public comment. So if you want to actually view it and see what's going on, feel free to go out there and look at it and see what you think and get it in your hands. and digitally. And hopefully September, we've got a new code that we can start designing with and offering our contractors and our owners. So